Hello class, welcome back to another section of my intensive for multivariable course. We are still on the vector functions, and in this class we are going to consider curvature. Curvature. Curvature is represented with a symbol K. When you say curvature, you know the curvilinearity of a curve. So how it's being curved. So in vector functions, curvature is simply given by K is equal to the length of the tangent, the derivative of the tangent, which we know the normal vector. This is what we call the normal vector, over the length of the derivative of what? Our vector function, which is also the tangent vector. So in a normal sense, this is normal vector over tangent what vector will give us the curvature. The length will give us the curvature. But we know that the t prime, originally t is actually equal to t of t is actually equal to r prime of what? T, right? Then t prime will be equal to t prime of t will be equal to r prime prime of what? T. When I introduce the length, then I'm going to get the length of my t prime of t will be equal to r prime prime of t. Then I put in my double curve like this. So r prime prime of t, but normally we use the notation. We use the length or the unit tangent vector and the unit normal vector in play. So let's see how we are going to make our substitutions. We know back again our t of t is equal to r prime of t. So therefore, if I get my tangent, unit tangent vector t prime of t is simply equal to r prime prime of what? T, right? So all over the length of r prime prime of what? T. But here, since I want the length from here, so I'm going to say all over the length of r prime of t like this, all squared. So it will be just the progressive part of this. So it was t, here will be over r prime of t. I find the length here. So when I come to the t prime, I'll get r prime prime of t over r prime of t all squared. That will be the length. So once I get this, I can make this substitution and I will come and put it in there. So normally we have another notation which is k is equal to the magnitude of r prime of t times, but we use cross, r prime prime of t all over the magnitude of r prime of t all cube. It's just from the substitutions you make. So once you get this, let's solve a question and see how we find curvature. It said determine the curvature for r of t, which is given by, so the r of t is given by angle t, 3 sine t, then 3 cos t. So once you have this, I'm going to use one of the formula. Let me use the first one. So you have to find the curvature of this function. So you put your formula down. K is equal to the length of my t prime of t over the length of my r prime of what? T. So what's the first thing I'm supposed to do? I'm supposed to find my t prime of t somewhere. So my unit vector t prime of t is going to be what? First of all, we will differentiate r to get r prime of t, and that will give me angle 1. Here will be 3 sine t, here will be 3 cos t rather, comma, negative 3 sine what? T. So once I get this, I've got my r of t, I'll put it down. Then I need the length of this, so the length of my r prime of t will be equal to what? Square root of 1 squared plus 3 cos t all squared plus negative 3 sine t all squared, all under square root. And this is going to give me square root of what? 1. Normally this and this will give us 1. Cos squared t and sine squared t will give us 1. But the coefficient which will be 9. So I'll just take 9 out and I'm getting square root what? 10 as my curvature. Sorry, as the length of r of t. Now let me find my t prime of t, which is also equal to my r prime prime of t. And that is going to give me angle 0. Then the 3 cos t will now be negative 3 sine t. Then negative 3 sine t will now be negative 3 cos t. Cos t, like that. So at this point, I'm going to find the length of my t prime of t. And that is going to give me r prime prime, the length of r prime prime of t, which is equal to the square root of the expression 0 squared plus negative 3 sine t, negative 3 sine t all squared plus negative 3 cos t all squared. So what am I getting for this? My 0 is 0 to go away. I'll get 9 sine squared t plus 9 cos squared t. And this is simply equal to 9. Square root of 9 is equal to what? 3. So I have 3 here. So my k is simply equal to the length I got here 3 over my r prime. The length as I got is simply equal to root of what? 10. This is simply my curvature. And how you find curvature is a formula work. So you just find the various components of a formula, then you solve it straight away. So I had a problem here which you will solve, but we post it into our tutorial classes. So don't forget to subscribe so that you get access to all the videos and the classes I'll be posting. Thank you.